Right, there we go. Right, so the stream is live again. Right, where are we? Right, so last stream was actually like a few hours ago, but then dinner, some family stuff, so we can actually continue now, but it's cool. And just before the stream, I have been tinkering a little bit with the PVH, and we're actually close. Let me show you guys this. Right. Let me get proper in my chair, right, and not lean back like a caveman, right. So when we run it now, I'm really fucking excited for this. Look at this. Bam. We have the outline of a cow. It's actually working. I mean, it has problems, obviously, right? But we can clearly see the object here. It's definitely doing something. So, there were actually multiple issues with the BVH in the end. Let me walk through them quickly. So, one of them was, I don't know how this ever worked, right? But on top here, I checked if the current node intersected, then we return a null pointer. What is the weirdest thing ever, right? Because that would mean that if we don't hit something, we continue. And obviously we're never going to intersect anything, right? So it should be if we don't intersect. So I actually figured this out like 2 minutes ago, right? This issue. The second issue had to do with this. So apparently I was passing in the wrong count here. So that is fixed. Actually, let me clear the chat so I can clear my chat. There we go. So it's a bit clear for me what's happening. Right, so that was an issue. But now, I'm just curious why we're missing the rest. Okay, I actually have an idea. What if... I might have an idea why this is actually happening. So, let's remove this if statement, right? And then have it go first. Because I think it might skip... Okay. That's even worse. Okay. Right shape. Oh! So this should be left shape. So there was another bug. Let's see if the cow magically pops up now. No, that would have been a lot to ask for, right? However, we can still comment out this and this. And if I'm right, and the skipping part is wrong, we can't... No, okay, it's not the skipping part, I think. Because I'm thinking, well, maybe we can't skip it because it's actually closer to the object inside, but it's not the case. Because now we're doing left and right, and then actually intersecting again, and doing the thing, right? So that's not happening. So we have current node left, so just making sure this is correct. So the right is +1, just left. Okay. So the if statement, I think, if you put this back, this is the exact same again, right? Yeah, this is the exact same. Cool. Okay, so we're missing still. So one of the things, let's begin cleaning up this code a little bit. We don't need this thread local map anymore. This is some stuff I did for debugging. Right, Right, so this should give me some errors. Test map, yeah, cool. Don't need this. Garbage. Garbage. Don't need this. Cool. So, I'm guessing the traversal's now wrong, right? Right, so let's come with this a bit, right? So check if the current node is a leaf node, right? So if it's a leaf node, then we find closest objects, right? That's clear, I think. Right, we need to remove this code in the future. Right, so if it's not, so if current node is a branch node, right? So if it's a branch node, then we have distance to the left box, distance to the right box. Okay, so hit left and hit right is left and left plus 1. These are set correctly. Okay, cool. So if hit left and hit right and GLM, right, so if they're the same thing, we traverse both, but right, I'm just curious about something, right? If left shape, right shape. Right, sure, let's, I just want to try something, right? So we comment out this, and we comment out if true. So this will just always fires, right? I'm just curious if this will give us a cow. It doesn't. Perfect. I guess. Not really, but right, we might not even need this part, but right, so let's remove this as well. Right, so in case we have, oh, right, no, I realized something, right? So even if this code fires, it just returns left shape, but it shouldn't. It should first do these things. So before it returns, we need to find information about the shapes. Right, so this should be outside of the else statement. So just check. Hey, that's a cow. That is interesting. So would that mean that this fires? It might fire, but that's okay. It does fire. Right. Right. So we have two boxes here that are so close to each other that we can't differentiate between them. We don't know which one is hit first, so we need to traverse both of them. However, does this get fired as well? Yes, this does, right. So, okay, this is big. So, if we know one is closer than the other, sorry, if we know one is closer than the other, we can skip things. But if we don't know which box is closer, we have to do both. So we're still getting. Wait, Ray, holy. Wait, Yessie. Thanks, man. Awesome for the rate. Thank you very much. I mean, I know you were here earlier as well, but I didn't expect you to actually stream as well. Wait, I didn't know you streamed, man. But hello everybody, welcome to the stream. Okay, right. Let me explain real quick what's going on. Right. So I have been. Yeah, I know you were here with the programming puns, but I didn't know you streamed, man. Right. So I'm working on the Raytracer, and I finally got the BVH working. We now finally got the model running. So I was working on spatial partitioning. So before I was running the cow model, and it took about 4 seconds to. Yeah, well, yeah, I think I'm almost there. We can see the model now. So before it would take about 4 seconds to render the cow. Now it's taking, or for 4,000 milliseconds. Now it's taking 30 milliseconds. So the Raytracer is now. No, I don't think so. This thing has taken me way too long. The spatial partitioning, it actually took forever. So now we're actually rendering the cow in, I think, 30 frames per second, if I remember correctly. So 1,000 divided by 132. I'm seeing 32. Oh wait, calculator work with me. Yeah, so it's a bit over 30 FPS for running this cow. Thanks, Jesse. But yeah, we're working on the Raytracer. Right. So the biggest issue that I had with the yeah, I'm rendering a cow. You can see the outline here. But for some reason, I don't have shading. So actually, like 5 seconds before you rate it, Jesse, I got the cow running. Like, yeah, sure. Give me 5 minutes, and I can give you a potato. Right. Yeah, I'm getting you guys a potato. I just need to get the model, and I already found the model. Now I just need to put it in. There we go. Right, there we go. Raytracer. So now we should have a potato. In theory. Oh, I think we got a potato. The angle is a bit horrible. Wait, let me show you the model I'm trying to render. Give me 2 seconds to get the to change the stream settings. Right, so I have been I'm trying to render. Why do I still have the whatever main display? Right, so this is the model that I just downloaded, the potato model. Right. So I think I can move the camera a little bit to gain a better view of the potato, because I think the tomato is a bit skewed to the right, so bottom right. So I can fix that real quick if I can actually find my main file. So the camera is, let's move it just a bit more back to like about 20. Hello? Okay, there we go. Oh, I disabled my numpad. That makes sense. Right. So as you guys can see, the Raytracer is like still in very, very early development, right? Because I really wanted to add. Okay, there we have a potato apparently. It's still very square, but we can see. I can actually show you that it is a potato. Not in this thing though, but 3D. Right there. No, that's not what I wanted to share. Fine. Apparently that doesn't work. Right. So this is the OBJ that we load, right? However, I think it's rendered like this instead of straight up. So I think I can maybe translate it, edit. No, I don't think I can. Open with Paint 3D. Oh, I can open it in Paint 3D. Skip. So maybe we can rotate it and actually get the potato shape in. That would be cool. Because transforms is also one of the things I haven't implemented yet. Although implementing shading now would actually be very trivial. Once I figure out why it's all black. Okay, so it seems the Paint 3D is incorporating. But yeah, we could theoretically render any model now. So that's pretty cool. You know, I don't actually have to... I just realized I don't actually have to rotate the model. I can simply do the following. So this is at 0, 0. And the Y would be at 15. And it's looking at... 0, 0. Right, there we go. So now we should be looking down on the potato. I think. I'm just crossing my fingers and hoping it works. It's taken an awful long time to render. Interesting. Why is it taking forever to render? This scares me. Yeah, I think somebody burnt my PC. Okay, wait. This is actually bad. Right. So, if I go in Task Manager, right? Look at this. It's like legit frying me in my CPU. It's actually insane. Oh yeah. Oh, oh shit. I think Visual Studio actually crashed. Right, let's give another try because apparently it just got stuck on the BVH. Yeah, it's a Ryzen 1700, so it shouldn't be a potato PC. I am just confused now why it's not rendering the potato. Because I changed nothing except the camera position. It shouldn't. It should be fine. Right. Anyway, it's hard to show what's going on without the shading. So yeah. And I don't know how well the model is, how many triangles it has. So it might simply take forever to build the BVH. But yeah, now we should have a cow again. Yeah, there we go. So we have the cow. However, I think there's something going wrong with the shading. But I have a feeling it's something very simple. What is just this? This distance is wrong. So I think we're passing this in, but it might not be used. So it's still at infinity by mistake. So I just need to... Oh, okay, it's just taking a while to build the BVH. So VS Console. Right. So it's hitting distance. Yeah, distance is infinite. Right. So this is actually an easy fix. So we're passing in the distance here. And then... Oh, right. Yeah, I remember. Right. So this shouldn't be... That one shouldn't be that. That should be simply T. Right, I remember. Cool. I've done this before and I messed it up. So now we should actually have a cow with shading. In theory, we should have a cow with shading. Alright, let's go back to Raytracer and see if there's still infinity. Because it shouldn't be infinite when... once it hits here. Oh, and of course it doesn't trigger because it's debug. It's release. So what might happen is that now I pass in the T correctly, the distance. However, it doesn't... I don't copy it. I don't take it as a reference into other places. What I'm guessing is happening. But there's a very easy... We can just test it here if the distance is correct. Because what happens, right, if the object is infinitely far away... okay, no, it isn't actually in this case. So it uses the distance here for calculating the intersection point. And if the intersection point is like literally at infinite distance, it's never gonna... the shading is gonna be black, right? Because the point from the intersection point at infinity is infinitely far away from the light, so there's zero light at the object. Sorry for my rambling. But yeah. So the intensity here is simply 0. What is interesting? Oh, what if my light is inside of the cow? Let's put this at like 6 and 6. Right, let's put it a bit farther away, because if it's in the cow, the shading might be the wrong way around. What I suspect is happening. No, that's a shame. Okay. I hope for more. But look at this. We're actually rendering this model now even in debug on, what is it, like 4 frames a second? 3, sorry. Before it would take just like 30 seconds at least to render a single frame. And now it's like insane. And you know the funny part, right? If we build a BVH around the BVHs, we can have 1,000 cows rendering, I'd say 20 FPS still. What's insane. And in release, that is, right? Not in debug. Debug is fucked. If debug renders 1 FPS, I'm happy. Because that makes it debuggable. If it runs in... I mean, would love it to run higher, of course, but... yeah. Yeah, if you guys have any questions about the Raytracer, do definitely ask, because I love talking about this. Oh. No, I don't want to full screen this. Alright. Oh yeah, ask away. So the cow actually has a bit of a backstory, right? So, last year we were, sorry, not last year, last school project, we were working on a custom game engine, and in the custom game engine we were writing a custom. We were starting from scratch with DirectX 12, what is quite a hard framework to get anything working in. So at some point we got very close to getting a model working. So what did I decide to render? A cow. And we got this purple cow rendering. This was the first model like our engine produced, besides like the standard boxes, right, that you just pass in for any rendering test. So yeah, that's why. However, you know, if it will make you guys happy, we can simply keep using the potato. I would actually be okay with that. The only thing I need to check is the model, how big it is, because I don't know how many polys it is. It might actually be easier to run. Oh, it's definitely not happy. It's definitely a big model, I think. I'm pretty sure it's like an actual huge model. Can 3D... can I see in 3D viewer how big the model is? Right, view... tools... Right, stats and shading. It's 80,000 vertices. So that would mean it's about 16? No, 15 times more triangles than the cow. So that's quite a lot. So let's go back to the cow then, because the BVH takes quite a long time to build. That is actually one of the few things I still need to do, is have the BVH actually be saved on a file, because that would be awesome. Right, so let's figure out this shading thing, why it's all black, because that shouldn't be happening. Because at least we now have the correct models. And I can get rid of this info as well soon. Because now we're getting the correct intersections, so the shading shouldn't be black. However, there might still be something obvious wrong, so I'm just going to check these values when it's running. Right. Oh, okay, apparently I'm not, because Visual Studio decided to take a dump. Right, let me rerun this. Oh, by the way, Lemify? Is that how I pronounce it? Lemmy? Thanks for the follow. Right. So out is 1, that's good. So the distance is 118, so that should be still quite strong. And .l, this is negative. How is this negative? No, Stefan, it isn't. I did render the cow now, though. Stefan, wait, let me show you the cow. We got the cow now. And it's much faster than before. So maybe we can render Skynet at some point. But, yeah. But why is this negative? So wait, let me check the light direction. Huh? That's odd. Because the light direction so positive Z is towards me, negative Z is into the screen. Yeah. So this direction is towards me, that's correct. It's up and to the left. Okay, sure. Intensity is 0, right, because this is negative. So interesting. Is there normal inverted? Are we getting the wrong normal? Because we are rendering the cow, but what if we're... let's try, for shits and giggles, inverting the normal. Let's see what happens. Because it almost looks like the normals are inverted, causing... Okay, no, that doesn't make a difference. So what I was thinking is that if the normals are pointing for some reason the wrong way into the cow, that would cause the light to be, black, because shading. However, that's definitely not the case, because if it was the case, this would have been positive. We should have seen some shading. So, let's go back here. So, I'm curious how it's even negative. Let me actually store something. So in here we're getting the normal twice. So glm vec3 normal, and that is the triangle dot get normal. Right. And now we can now we actually have this backed up somewhere, and we can actually inspect the values. So the normal should, in theory, wait, how did I save Nico in D&D, Jinx? Oh, that's awesome. That's awesome. Yeah, don't get distracted, Siphon, by Skynet. It's Batman. Yeah, no problem. It's a pleasure sabotaging Siphon. Right, so what is this? What's this normal value? Okay, so this normal is pointing into the screen, what is interesting, to say the least. So, what if I just invert the Z? Normal.z times equals -1. I'm curious why that would matter suddenly, but you know, it is what it is. Or we could be rendering the... Okay, no. I had hoped for too much. It was worth a shot, but no. But it's actually a good point. Why is the normal pointing into the screen in the first place? Because that should never be the case, right? Oh, ships. Because if the normal is... I did something weird here. I clicked some weird buttons, did something weird. Debug. Right. Yeah, sorry, I was thinking, right. So if the normal is pointing into the screen, that would mean that we hit the back of the cow, right? Because... Yeah, let me use my hand as the cow, right? So if this is the front of the cow that we're seeing via the camera, the normal should be pointing this way, right? So this should go this way. However, the normal is actually going this way, with pointing the wrong way. What we can see here, right? So this normal is pointing to the left, down, and into the screen. What is completely wrong? Although... Interesting. So, what if we're simply hitting the back of the cow? But that would still be weird. So, a weird idea, right? What if we, instead of at 6, we put this at -6? So that way the light should be on the other side of the cow. That should produce positive lighting then, maybe? Oh, we can see. But at least we're rendering the model, so that's something. I'm just confused why we're getting... now it's positive. Okay, it's still black, but we're getting positive values here now, at least. However, there's still distance. Distance is not very far. So this is 3. So the intensity is very low. Right, so what is out here? Right, so this is almost black still. So why is the intensity... Right, because the light is still basically... Right, let's say, what if I put the intensity like way up, right? I'm not saying this is a good fix, but we're at least getting positive values, so this should give us hopefully a color, at least. And if we get some colors, it's going to be easier to see what's going on. Right, so what is the out now? Yeah, that's definitely working. That should be between 0 and 1. Right. Yeah, that's definitely shading, right? It's a bit intense. Oh, ships. I've got to admit that. However, we can definitely see it's doing some kind of shading. That's interesting. So, what if I put the intensity down to the 100 I had? Instead of... let's just put this... Oh, wait, this is down. So this should be 6, but instead of there, we put it at 0. So the light should be right above the cow now. Let's see what that does. Right, so it's still black. Okay. I am actually very curious why it's black. So why I think it's odd, right, is when I did this before, when I just go over all the objects and get the closest, it would work. It would give me proper shading with the light placement that was at. However, that doesn't seem to be the case now. What's interesting. So, what if the BVH traversal is still wrong? So it will give me the object distance, right? So yeah, no, we're still doing the same basically, right? So we intersect. If it's So what if we intersect two objects, but one is closer? No, that wouldn't matter. It would still get the closest in the other end, right? And it's all the same. It's all the same flow in the end that we're referencing, so that's fine. And this is all called with object distance, so that's fine as well. Oh. Wait a second. Right. I think the issue might be here. So we're saying this is distance between the two objects. No, that should still be fine because I still got the closest distance in the end. Yeah, okay, right. No, the problem was that we didn't know which distance to the object was the closest, so we have to intersect them again to see which is the closest. However, I think we could improve this, but for now this should be fine because we only care which object is actually closer. It's still the closest in the end because this is the same variable, so it just compares it between the max that's infinity. So what if I put this to -5? So we're still not getting shading. What's odd? I would like to say it's correct, but it's clearly not right. So let me show you something else, right? So if I put this to, let's put this to right above the cow again. And I think I still have the old code in the BVH. So if I comment this out and recomment this, I do need to run this in release because otherwise it's going to be really slow. We can magically see that it has shading. Fingers crossed, right? We have shading now. It's still pretty dark because it's on top of the cow. So if we move this light a bit forward, so it would be about here, right? We should now have better shading, a bit more in front of the cow instead of on top, giving us better shading. Yeah, so now we have the proper shading, and the difference here is that we can see that we're back to the long ass intersection times. This is running. I mean, you can't see it because the console decided to be a pain again. But it's taking about the 6 seconds again to render the frame. So the only difference here is that this loops over all the objects and get the closest one. Like the BVH code should do. so it is the same check, right? So if it intersects, and if this distance is less than t, then we set the closest shape, right? So that's pretty much the same. However, it's clearly not doing that. Oh, I have an idea. Wait, did I? Right, let's stress something. So in the shading, I don't know why I didn't check this earlier, but what we can do, right? So we calculate the intersection point. Is this intersection point even in the triangle? So it's 2. Yeah, something like that. All right. So let's check the x-axis first. No, wrong button. Work with me. No. Okay, this is interesting. So the intersection point can never be true, because see all the points, right? They're all like -3, -3, -3. However, the hit point says like 2 point something. So our distance is wrong. So that means that the triangle that we're getting is somewhere here. However, our hit point says we're here. And obviously we're going to get wrong shading if the point is wrong that we're actually hitting. So the hit points, this would actually be like down somewhere very deep. So that's interesting. So this distance, right? Cost stack. Right, let's put a breakpoint here and see this distance, because this distance must be wrong then. Oh, it's wrong at release, right? Let me put this to debug. Right, so if my suspicions are right, we're simply getting the wrong distance. But that should be a relatively easy fix, I would think. Because then there's something just going wrong with the selection of the triangle. Right, so the distance is 19 something. Right, so this results in something I can't see, right? So if we go in here now, the hit point is at 2.03. Yeah, see, the triangle is somewhere completely else. So the distance is wrong. Okay. This is definitely wrong. Okay. But I can work with this. Now we know at least what's going wrong with the Raytracer. Right. So we start. So we pass in the t. We pass this in, right? So this will be infinity at the beginning, because we don't hit anything, right? So then we traverse. If we don't intersect, we early out. Okay, that's fine. This is the only place where we use object distance, I think. Yeah, so this is all just passing it along. However, this is the only place where we set it. Okay, so let's go a bit closer to this. So let's set this to no pointer. So the closest shape is a no pointer, because we haven't hit anything, right? So then we go over the amount of triangles in the node, and then we actually calculate the correct index for it. So the distance to target is infinity. So if we intersect, right, and that distance is less than the object distance that we passed in, then we should set the object distance to the distance to triangle, and the closest shape to this one. So, okay, let's see this in a bit broader view as well. So, say we have two objects that we intersect. It can get both of them. However, it will only get the closest in the very end, because this is all comparing this like this value. It's all passed by reference. So it means that only in the end this object can appear. All right. So I'm curious why this is going wrong. Because this should be like straightforward. I can double check with my old Raytracer. Yeah, it's still black. What I find very interesting. So with the old Raytracer, yeah, right. So we're intersecting. Although they were actually calculating the intersection point instead of the distance. What is D? Right, so objects. Right, so what this float represents, right? This is the steps from the ray origin that it needs to take. So the smaller the number, the closer it is. What should be completely fine, honestly. So we don't need this anymore. Right, so this D gets set here, yeah. Interesting. Very interesting. Right, because I'm guessing this might happen, this situation. Let's just run this and see what happens. So the odd thing is, why are we getting a mismatch between triangles? Oh, I have another idea where this could be coming from. In case it's not this. Right, yeah, so this debug break is triggering because this distance to triangles like 19 and the closest is 19.3. Yeah, so this one is slightly further. Right, that's perfectly acceptable. And closest shape is no pointer, right? Yeah, cool. So that's fine. There's nothing really weird happening there if it misses. But what could be the case? What if, in this case, we have 2? Does this ever get fired? What if I'm returning the wrong shape here and we're getting flipped things? That could be still a thing. Right, so we do trigger this. So they're both infinite because I'm... Right. Okay, this is odd. This should be impossible. So, we got 2 shapes here, right? That we intersected, apparently. However, when we intersect them again, it fills. What's interesting. So let's add some pools here. and restart. So let's see what this does. Because if this happens that it's missing two items that it's already intersected with, it's false. That's very peculiar. So, that should be impossible. That should be impossible. Huh? Because if this value, if these both exist, right, that would mean that we intersected them, because the only place left and right shape gets set is here. So they get set in a bunch of places. However, they get set in a bunch of places. However, the only place where we actually return, let's see, return. So we return here. This is the only place where we... The only place where we return a shape, I think, is here. Here and here. Okay. But when we return right shape here, we still intersected. So how can this not intersect? What is weird? That confuses me, right? So this is the only place where we set the like this is our like exit condition. So oh hey, we're looping over all the shapes. This is the closest one. We return, and this could either be, so this is coming from either here or one of these, right? From either one of these two. So we traverse them, and left or right is still traversing, but the only place it actually intersects is here. So if we intersect only then, we can get objects. So how can this fill? Because this should never be able to fill. So if this simply now returns either left or right shape, that's wrong. Because we don't intersect it. What's odd? So, why? Something I'm curious about. Let's say we do minus. No, we can't do that. That's not fun. That's actually very peculiar. Because it's kind of, I can't see from here where it's actually getting the values from. Because the stack already got destroyed. Or not destroyed, but the... I can go up the stack again, I think. I mean, I can try, but... They can only go down the stack. Because that's literally how a stack works. So they're both false. What is... So let's run this again, right? Every time they're false... So if this and right, so if left shape, so this would mean if it's not null, and if this is not null, because that's basically what's standing here. So if these have actual values, then do this. But the only way we should be able to get values is from that one point. If anybody has suggestions, I would love to hear them, because this is odd. Right, so by the way, for me moving around so much, I have issues sitting still. Interesting. This is actually peculiar. Oh. Right, so... Right, I remember. So the only place... Right. The only place we can actually get two shapes from is this function. Right, because with the other parts, if we have a left but not a right, we skip one of the nodes because we know the difference in distance. So the only place we could get two shapes is here, potentially, but both fail. So no pointer if no pointer. So let's see what this does, right? So this continues. No, this should fail because there. Null and null. This should fail as well. So it simply returns left shape, but it's null. Yeah. So what did I maybe do something wrong here? No, this looks fine. So how can we still intercept an object that's wrong? Sorry, how can we still intercept an object that we don't intersect? If that makes sense. Because these... So I think this gets triggered. Maybe... Oh. Maybe this one instead. Yeah, this gets triggered. These are both correct. So what if it just, in this case, right, return... simply return right shape. Just for the sake of argument, right? What if we're simply here returning the wrong one? And that's why we don't have shading. I'm just testing some things now to see if anything sticks, right? Because the more we try, the better idea we can get of why it's not working. Because if this suddenly works... No, okay, it doesn't. It was a tall shot, but... This should not be able to fill. Right, so before we did this, right? So if closest shape, right? So if we don't intersect, and then ray and yeah, we do need temporary valuable. And test, so if we don't intersect, then I want to debug break, right? Because this should never be able to trigger in this part of the code. If it does, I'm going to be very confused again. I mean, I already am, but I'm going to be more confused. Okay. This does fire. Okay. Interesting. So this failed. Oh! I see the issue. I think this is the issue. I think we found the issue. I think this is it. I think this will fix it. So we're returning I instead of the index. What's wrong? I don't even know how we got a cow with that. I like physically don't know how we got a cow with that. We have a shit a cow. Works. Holy shit. Awesome. This is awesome. This is big. So I is equal to 0 and count. So we're magically getting a cow with only like very little of the pulleys that were actually supposed to be there. I am so confused, but this works. That's awesome. Right, so now this actually works. So we don't need this piece of junk anymore. Although no, we can actually keep this. However, right, we need to find the usages, and yeah. So instead of this if, we can do. Nah, we don't need this. Who cares? Useless garbage code. Some stupid debug thing. Right, cool, that's all gone. So let's loop over this code once more to clean it up. Right, so this can go. We don't need that. That looks all good. Good. We don't need this anymore. Comments. Yeah, cool, that's fine. We don't need this function. This is all correct. Sure. This actually works. Let me just rerun this again. I want to see the glory of the actual running the running cow again. I am so happy with this. We got the shaded cow. Right. So let's copy. You know, I think we've got to celebrate this with a potato. So if I now throw in the potato in the Raytracer, this should take a while to build. However, it should still render in about 30 FPS if the BVH is actually performing like it should. It is. The performance difference is actually, it's still running at about 30. It's running slightly slower, but that's really impressive. It's so. Wait, sorry. So the console is not showing up. All right, no wonder you guys can't see it. Right, there we go. So the console's now there. So these are the. It might be a bit too hard to read on stream. However, these numbers are the time for each frame in milliseconds. So for reference, 16 is 60 FPS, and 32 is 30, if I remember correctly. So that means that we're running just under, or just above 30 FPS with this. What I think is huge. Because if we... I actually want to try something, right? So, I want to show you something, you guys. I do need to set this up real quick. So, if you have 2 minutes, I need to get another model. Program files. No, sorry. Right, so this is the Ferrari that I was running before in my old Raytracer, right? So let's build this. I think this is actually a really high poly model. It's going to take a while for the BVH to build with this, right? So this is still running in about 30 FPS, right? And although it's much more limited here, we can see some shading, but it's rendering kind of in a weird place. The old Raytracer that I had, Right. So this is running in 30. Let me show my main display again. No. There we go. This one. So this is the old project. This is the performance with the old one, right? So for stats, it's running at about 3 FPS. Look at that difference. And I can promise you this is running the this is the same model. It's how insane is that? And the only difference that we really have here is the shading should be identical. Yeah, no, we have some more shading with it has lights that it cares about. So it's a bit slower, but the performance difference already is massive. I mean, it doesn't look the same yet, of course, but that is insane. I'm so happy with that. Holy. Right, so now it's actually time for the most fun part of every stream, and that is Gitkraken. Right, so let me make this a bit bigger. So Gitkraken is what Gitkraken is a bit big. I make Gitkraken a bit too big. Let me fix that. Gitkraken, go back. Sure, good enough. So Gitkraken is what I use for planning, right? And it's also my Git client. So we can go in here, and what do we have? We have the building with the BVH complete, and we have traversal complete. And we can move this in the done card. Bang. So next, add a basic scene. Sorry, it should be in progress. Hey. So we're gonna work in adding a basic scene, and we need to push the current project, right? So this is added BVH. So what did we do? We added a BVH for models, and for models, and the ability to traverse through them and get the wait, sorry, you guys can't see my commit message. Right. I think that's readable. Right, sure. So added. So I think it's added a BVH for the models and the ability to reverse through them and get the correct triangle. There. That works. I think that works for commit message and commit. So it seems let's pull as well. Cool. Cool, this works. The Gitkraken can go again. You can go, you have done your job. You have showed me what I needed to do. And that is a scene. What is, going to be fun. No, I do actually think a scene is going to be one of the easier things to create. One of the easier things, right? So, in the Raytracer, we simply have a... No, we're going to need a new header. Core, new item, or sorry, new class. And this can be scene. Current tracer, include core scene, and source core scene. Right. It's been so long since I've added a class. Holy, because I spend like 2 streams now on the spatial partitioning, and I'm just so glad it's actually finally working. So this is Yeah, on getting this working, it's finally done. So let me actually rename the stream now as well, because we're now working on scenes. So it's a bit clearer what we're actually doing, because we actually skipped the spatial partitioning, the hardest part, and we're now going to the, well, easier stuff. So namespace RT, and this needs to include, this is core.scene. Cool. So what does a scene have? And a model should have a model contains a BVH. No, it doesn't contain a BVH. It contains an RT BVH pointer. So include core slash BVH slash BVH. Sorry, no, it should be just BVH. Right. So it contains an RT BVH pointer. Right, I just included that. I am including this. Okay. What do you want me to do? RT. Oh, should this just be BVH? Wait. It's namespace RT BVH. Why can I not do the... Yeah, this should be... Okay. Okay. Right, does this compile now? No. Okay, that's actually really odd. Okay, I suspect this might simply be Visual Studio messing up. So let's do this core slash BVH slash BVH, and then RT BVH pointer BVH, sure, and rebuild, and just force a rebuild and see why it's complaining. Oh, I see what's happening. We're getting circular dependency. I don't actually need to know about the BVH class. I just need to forward declare it. Yeah. Yeah, that compiles fine. Cool. Sometimes I swear I don't know what I'm doing with programming, or it feels like I don't know. Pin and pin, right. So what does a scene have? We need to #include vector. So in private we have a std vector of RT model pointers. #include core slash model, right? So we have RT model pointers, models. Now we have a std vector of... No, I don't even need to include this here either. I can just forward declare this as well. then a class light. Did I actually name this light, or did I name this? No, it's a point light. Cool. So we have RT a vector of point lights. And I think this should be, oh, and we have, of course, a STD vector of cameras. Yeah, sure. So we have camera pointers. And we have a camera pointer m.active active cam. Right, I did actually notice I'm messing up the naming because they should all start with m underscore. Right. Yeah, sure, they're not used, that's fine. Sure. So this is what a scene consists of. And then we need a struct with scene info, because we're going to basically need to construct the scene, right? So, because this is going to be the base scene class that we can use to inherit from. So we can simply say, hey, these are the available scenes. Just load in this new scene, or not. Although, do I want to do that? Yeah, sure. We can figure out a better way to, but we need some basic ability to describe scenes, what this is going to be. So, scene info, it's going to be uint32 num of models, uint32t num of lights, uint32t num of... No, I don't think we actually need this. Right. So this is our basic scene, right? No, I don't think we even have to make this a class. We can just make this a struct, right? And simply have bam, right? Have these be just available, and then instead of it should actually start with yeah, like this, right? Right. So with the Raytracer now, I think the Raytracer currently takes in nothing. Okay. How did I set the camera then? Oh, right, it's used to generate rays. Right. Yeah, that's interesting. I think we might have to move the ray generation to into the Raytracer. But sure. So this actually has a scene, so we need to include scene. No, we don't. So class scene, and this has a scene pointer and active scene, right? Active scene, and this is by default equal to a null pointer. Then in the constructor of the Raytracer, we don't want to build the BVH here. We want to construct a new scene. Right, and we do need to include, so like includes scene, core slash scene. Right, instead of unique pointers in here, this can be shared pointers. Yesterday shared pointer RT model. Yesterday shared pointer point light, and this is an yesterday vector of yesterday shared pointer of camera, and this is a yesterday shared pointer as well of type camera. Cool. So when we create the Raytracer, we want to render. Right. So let's change this in the Raytracer. So in the Raytracer, right, let's pass in, you would need a class strength, a class camera. So we need to pass in a SD, so a camera pointer. Do I want the cameras to be shared pointers? Yes. Do I? I'm beginning to doubt myself. I think I need, in this scene, I'm going to need BVHs as well. No, I don't, sorry. Right, so I'm thinking how I want to structure the Raytracer. Because I'm guessing, yeah. We want to pass in a scene. So an yesterday unique pointer of type scene. Scene to render. And then in the constructor, we simply set this should be as the unique pointer then. Of type scene, active scene, right? And m.active scene equals scene to render. Right, and they should be SD move, right? Because now we handed the scene to the Raytracer, and we can delete the scene. We move the scene to the unique pointer in the Raytracer, because the idea is, right, we construct a scene, and then we say to the Raytracer, hey, this is your scene to render. So it should be a unique pointer, because once it's created, we hand it over to the Raytracer. No. I'm saying something very bad. No, bad Livy. So this should be a shared pointer. We don't want to move it. No, because we might want to add things to the scene from somewhere else, not from the Raytracer. Yeah. This is a shared pointer. So m.active scene equals scene to render. And then we want another function here, what is simply void change scene. This takes in a scene, and this is new scene to render. And this will simply set the m.active scene to be equal to New scene to render. They shouldn't be capitalized. Right, and then in here, right, we need to change this code a little bit. So instead of just looping over the triangles, we need to do it for all the, so there's going to be m.activeScene. Oh. m.activeScene dot models dot size, and then we copy this, and hit should be outside of here. Hits sure. Oh, and they should take another float. So this should be current model distance, and this is set to infinity, and current model distance is less than distance. If so, hit is true, and distance is equal to current model distance, and then we should pass the current model distance in, right? Oh, and then sure. So this should be renamed to current model triangle, and then we want another one here. Oh, closest triangle, and closest triangle equals current model triangle, right? So this will give us that. So for the shading, we need to loop over all lights. Oh, sorry. So there should be m.activeScene dot point lights dot size, and this shouldn't return out. This should simply so this is glm vec3 current light color, right? So this will simply say so else out plus equals current light color, and this is set to 0 because we it's a bit default, right? So if m.activeScene dot point lights dot y dot intensity, oh, and this should be this one. Then, right, so this needs to, I need to get rid of this light. It's going to make things a bit easier. However, we can do a const rt point light reference light equals and then dereference. And light dot intensity. Cool. So that works. So now this is current light color. Can I just do... yeah, I can just say light color, right? This light dot... No, this would be the... No, sorry. We do need this because this is currently the diffuse of the object. What we don't have added yet. So this still does the thing, right? And then it should modify out. It should modify... yeah, and then this should return. And this should be out plus equals... No, it should be current light color. And then... No, we don't need this else here. We can simply do this at the end. So we add this and then bam, we add it right at the end. So now we have support for multiple lights. So this is a decent scene structure. However, we still need to change this in the main. So we create the Raytracer here somewhere, right? So we need to include the scene here. Hashtag include core / scene. So we want to create a new scene here. RT scene, test scene. Right, so test scene dot point light dot pushback as today make shared point light Sure, so we can add a type of point light here. Oh, yeah, right, so RT point light. Why does this not work? Oh, I need to include point light. Okay. Right. And then I need for the values, I will need in Raytracer, I will need these values. Why are we complaining? This is literally all you want. You have your position, you have your color, and you have your intensity. What more do you want? Oh, I do need a RT point light here, right? And that is wrapped in this, right? I think I don't even need this. I think it can figure this out. No, we do need this, right? So we're making a light shared. Then we need a yeah, no, lights, we can simply do that. But then for the models, I'm going to want a resource manager. Because we don't want to load models twice and BVHs twice. We simply want to reuse them. So core add. So first, actually, we can remove the scene.cpp. We don't need it. Remove. No, delete. Get rid of it. We need a second class in core, a resource manager. And then this should be in current tracer include graphics. No, sorry, this should be in core. And this should be in core as well. No, not in the include, sorry, in the source. Source core, bam. Right. So we now can work on the resource manager. So this resource manager is not going to do too much. What it's simply going to do, you pass in a string like, hey, I want to load this model. If this model exists, return it. If it doesn't exist, load it in. And same for the BVH. And this should be core. Right. So we want a std shared pointer of type class model, shared pointer of type model, load model, and this takes in a string, so we need to include string. So take in a const std string reference, const std string reference of file path, right? And then in private, so this is public, we want a std unordered map. Unordered map of type std string and std string and std shared pointer model. And this is m.models. And then we include nerd map. Oh, right, we need another bracket. Sure. So load model, what does this do? So if m.models.find file path, if that equals m.models.end, well, it doesn't exist, so we need to load it in to do load, else return m.models.filepath. And there should be a const. This returns a const shared pointer. No. That's fine. We do want to be able to modify them to do load. So this should be m.models.filepath equals std make shared rt model. Then we do need to include model here. And then we want to simply pass in the file path, I think. Right, how do I construct the model? No, how did I? Oh wait, I have to do it differently, right? Yeah, so I do model. Right, I need an Obj Loader. Cool, sure. Yeah, so this can simply be in the resource manager. Yeah, we can just include this. No, we can actually make this a unique pointer. Unique pointer of type Obj Loader. Obj Loader. Oh, oops, this is in the wrong place. And then this should be in the CPP. And then this needs a constructor, resource manager, m dot oh, this is not underscored correctly. So this is m dot obj loader. m.obj loader equals std make unique rt obj loader. Cool. And this is a m.obj loader dot load model file path. And it returns a unique pointer. And I'm guessing that's not okay. Yeah. Can I just move this in here? No. Okay. So it's not a unique pointer, it's a shared pointer, because we're sharing this object around. So load model, so this should actually return a shared pointer. I think I do a make unique here. Yeah, so this should be make shared. And then bam, make shared. Why is this not okay? Oh, SDA, sorry, shared pointer of type model. Yeah, cool. Oh, and this is of course a shared pointer. Resource manager, Obj Loader. Yeah, so that's a unique pointer. This is a shared pointer. And we don't need to make shared. We can simply say, hey, bam, that's now equal to that. And we do actually want to add something here. This should be marked as no discard. No discard. Because although it's technically safe to discard, we shouldn't discard it. Oh yeah, this is still complaining. Cool. That's fine. We don't want this anymore either way. We don't need this either. Cool. So in the resource manager, right. So if it doesn't exist, load it and return. No, sorry. As a unordered map, and this the key is the SDA shared pointer of model, and the key is an SDA shared pointer of type BVH. So we need class BVH, and this is m.bvh. Right. So m.bvh m.models.file path equals SDA make shared rt bvh, and we do need to include this. So include core /bvh/bvh. And to do this, I need to pass in the model, I think, just the model. Yes. No, wait, I don't think I have to do anything. No. We do want this, and then we want to do build BVH, and this passes in m.model.file path. Right. Right, so we do need some slight modification in this. So this takes in not a model reference, this takes in a SDA shared pointer of. No, I could just do a get, sure. Oh, I deleted something here, right. So resource manager dot get and dereference it. Cool. So that builds the BVH now. And okay, no, we can't actually do this. We need to copy this, and then m.bvh m.models .file path build bvh, bam. Right, and then we said we need to set this dot. No, sorry. So this should be. I mean, this is not a very elegant way of doing it, but whatever. So what is this BVH? So this is just a BVH pointer, right? We don't want that. We want to include memory. So there should be a std shared pointer BVH. BVH. And the resource manager .bvh equals perfect. This is horrible syntax, but that's okay. So now we load in the model. We set the BVH immediately on construction, and right. So we need a test scene, and we simply pass in the test scene here, right? So wait. So this takes a unique pointer, right? So the unique pointer, no, sorry, shared pointer. Of RT scene. Equals std. Sorry, so test scene equals std make shared RT scene. Right. And then test scene point light up pushback, right? And then we want the resource manager as well. However, this is a shared pointer as well. So hashtag include core / resource manager. So we want to create a std shared pointer of RT resource manager resource manager and this is of type std make shared RT resource manager. Wait, sorry, no, std resource manager, not Raytracer. So then we want to simply say, oh, there's a comma here, and then test scene dot models dot pushback resource manager dot look model cow dot obj. And I can do this again with the Ferrari. I should be able to. And they're on different positions. So that should render. So this is in the Raytracer. Oh, right. So this. Right. So this is. Didn't I? No. Okay, great. So this is m.activeScene dot models dot y dot bvh dot intersect, and this is right. We still have 2 errors. Can delete. Oh, in main. So we're forgetting to include the Obj Loader. Okay, but that should be done. Interesting. So is this included in here? It is. So why do you need the Obj Loader. Is it because it's declared in there? Oh, did I create an Obj Loader in main? I've got a bunch of files open I don't need. Main. Cool. Oh, it's the resource manager. So maybe I do actually need the Obj Loader in there. So hashtag include core slash Obj Loader. Did I spell it correct by any chance in the forward definition? I did. Right. So let's see if this builds. No. Right. So with the load model fills. Okay. It might be because I simply don't know what a model is. However, we include. No, we don't actually. No, we do include model. So why is this failing? Wait, maybe it's the no discard thing. No. So it's the shared RT model. Right. Resource manager. Interesting. So why does that fail? And why does this fail? I hate linker errors. So we don't have memory actually. That could be the case. Right, no. So what does the output say? Right, so we're missing something. Cool. We have string included, we have an map, we have memory. What else do we use here? We use model. No, it's not that. Right, so let's just delete this and just redo it. Just say, hey, I want to generate the implementation again. Just copy paste this, see if it builds. Maybe it simply can't find it. By the way, Soxol, thank you for following. I just realized that now. Sorry, I didn't pay attention to the following thing. My bad, but thanks for the follow. Not all. Oh. End result external symbol. Yada yada yada. Oh, do I maybe have a circular dependency? I doubt it, but nothing weird there. The PVH does that include? It does include model, but model doesn't include it, so that's fine. And it's crashing in. Oh, could I okay, right. So in main, right, it's complaining about the load model. So it's complaining about this. Build, rebuild. build Raytracer. And okay, so that succeeded. Right, so why is this failing in the main? So why is this function specifically failing? Do I have string? No, I don't actually have string. However, that should be included when we include the resource manager. Right. Right. Pushback resource manager load model. So there's an unresolved external symbol, public class SC# pointer class RT model. Yeah. Right, can I do this? Is this fine? So simply, no, this is still the same thing, right? Okay. So the moment we call load model, we're not including something. So we're including model, we're including the Obj Loader, we're including the BVH. We should be including string from the. We should be including string from the damn PCH. No, it's the actual load model that's providing issues. Is it because this is not namespaced? It should be fine. What if I make this a struct? Oh. Is it actually model? Just it is, okay. Right. Alright guys, I'm gonna take a 2-minute break. I'm gonna go grab a snack from downstairs because my brain is running out of fuel. And a quick walk might help my brain get kickstarted again. So I'll be back in 2 minutes. Sorry for the wait. Right, I'm back. I got some cheese. I'm ready to think again. Not that would go well, but right. So we're getting a thing, right? So let's think. Let's say we just make this a RT model pointer. Right. So return, and then we simply do need to get this. Right. So let's write this, right? So now we're simply returning a pointer. Right, we can't do this. Because this is still expecting check pointers, right? So we need this. Yeah. Right, that compiles fine. Okay, so there is something wrong with the load model with the shared pointer part. No. So this is just something nice. These should be right, sure. And then in resource manager, sure. So let's just include model. Right, and then delete this struct. And then we don't need the get here either anymore. Right, does this compile? It does, okay. I don't know why, but sure. I'm guessing it must know for some reason what the exit class is, right? So then test scene, we need the cow. So does this compile? Yeah, okay. Then we go to models. Still running a bit above 30 FPS. Sweet. So yeah. So this should be let's put this at -4, right? We will make this light instead a bluish hue. And then in the Raytracer, we do need this to have a red channel as well. Right. So it should be a bit more light play, if you want to call it that. Right, oh cool. So we're getting some stuff there. I think this is working. But multiple lights, I'm guessing. There is some weird stuff going on with the car. However, that might be multiple things. I can't confirm what it is still. We can rotate objects. But shit. Okay, I didn't chew my cheese well enough. I almost choked on cheese. That would have been sad. Right, this works. Yeah, this is cool. I guess it's now time to throw in... No, I think that should actually be enough for the basic scene thing, right? We have very basic scene support now. That's all this card was actually about. So let me go back to Gitkraken. Right, so the basic scene is done. So as for comments, very basic scene support to that allows for what the scene allow for multiple models and lights. Cool. Add comments. And then for this, view changes, stage changes, added a basic scene. So added a basic scene structure. And added a basic a resource loader for the models, right? And that should be enough for the commit. So I think next up it's time for, what do I want to do? I'm GUI could work, but I'm not really in the mood for I'm GUI. BVH for the entire scene would be smart, but I have a bit enough with BVHs for today. Maybe reflections. Sure. You know what we can do? We can add materials. So this is a feature. And add a description. No, we can just do a task list, right? So what does this need? Support, base color, I think that's it, really. Oh yeah, fair. A reflection and refraction. Right. So it needs, the material needs to support those three things. Although reflection and reflection are very simple, for the base color I do actually want to fully implement that in the Raytracer. Cool. So let's close Gitkraken again and work on a material. So we want to add a new header, and this is going to be material. So for the material, we need like 3 variables, right? We need a glm vec3 base color, and this is equal to 1.f, 1.f, 1.f. By default, a float, reflective index, and lastly a float refractive index, right? So this is really all we need for the material at the moment. We like with just these 3 values, right? We can achieve some pretty cool results. This is wrong. Refractive. I definitely spelled that majorly wrong. Right, there we go. Refractive index, right, there we go. I am dyslexic as hell. Oh, where did my music go? My personal music. Cool. So we have the material. Then in the model, where did the model go? Right. Yeah, cool. There's an std shared pointer of type material. And we want to forward declare this as struct material. And this is going to be material. The reason why we're making this a shared pointer is because multiple objects can share the same material. So this way I don't have to set every material for each object. I can set a specific material and it will automatically change accordingly. So then in the resource manager, we will need a new unordered map. Unordered map std string, and std shared pointer of material. Right, and this is materials. Right, so std shared pointer material, get material, and this is the const std string reference file path. Right, so this is going to do something very similar. So if materials.find, and this shouldn't be file path, this should be material name. So if material find does not equals m.materials.end, we simply want to insert it. m.materials.insert std make shared material, and then we want to include core slash material. Materials dot material name equals std make shared. Sure. And then we want to return this, and else simply return this id array. Cool. So that way we create a material. If it doesn't exist, then if so, we create it. Right. Then we want to say in the main, so let's create yeah, right. Let's create a material first. So resource. Right. So test scene dot. So let's do an RT material. An STD shared pointer of RT material, and this is red material. Right. And this is from resource manager dot get material red material. Right. And red material dot why can I not do? Oh, I do need to include material. Let's include core / material. So dot material dot base color equals 1.f 0.f 0.f. Cool. So resource manager dot load model cow.obj cow.obj dot material equals red material. Right, so now we should have support for the materials. So now this cow should be simply red. Oh, no, right, no, that's never gonna work. Well, it is going to work, but we're going to need a slight change here. So this should be ooh, right. Right, I have realized something. This is going to be problematic because this will give the entire model a material. However, we want to give the what do you call it? The each triangle a material, right? Because we can give each triangle a different material. Yeah, that would be better. Yeah, no, I think for now I don't care about that. So m dot active. So RT model equals all right. We need the model. However, we can simply get the material. So RT material pointer material is no pointer, and if we hit, we want to only if we hit, we want to just get the material. No, we need to set this here, right? So material equals m dot active scene dot models dot y dot material dot get. Right, and then in here in the apply shading we pass in the material. So so a RT material pointer material. and this can be const. And then we need to struct struct material. Right, then we need to add changes in the shading. Save the material, and then we pass in material, and then material dot. So this should be material dot base color. Oh, we don't have the. Oh, right. Right, base color. Cool. So now we should have a red cow. Okay, that's cool. Right, so if we create a model, we want to assign it a default material. Sure. So in the resource manager, we want to m.materials dot default equals std make shared rt material. Cool. And we want to say this dot material equals m dot materials dot default just so we have a material by default what is going to be white and no reflection and refraction. So it's still there. We go. Now we have a red cow and we have, I think, a whitish grayish car, which should be fine because it's 111. Cool, that works. Yeah, sweet. Now it's time, I would say, for adding a transform. Well, it's going to be quite a long or annoying process, I should say. But it would help actually a lot with the camera controls. However, you know what? I think that's going to be something for tomorrow. Because I have been streaming for about 2 hours and a bunch more today, I am getting quite tired. So what I'm going to do is see if I can raid somebody else maybe. Can I see mod view? Oh no! What the hell is this? I guess that works. I didn't quite want to see that, but sure. No, I'm trying to figure out how to raid. Oh, okay. Right, so I think I could do just /raid and then a channel name, right? Okay. So let's go find a cool channel. So Twitch. Right. Science technology, and then I want game development, right? Let's see if there's anybody doing something with C++, right? C++. No. I can't find anything. That's a shame. Programming. Cool. Okay, let me see if there's anything cool. If you guys know any cool channels as well, I would love to rate this as well. There are not that many coding channels. That's a shame. Oh, that looks interesting. Right, cool. I think I found a decent channel. Right, so I think I can do slash. Right, I think that works maybe. Right. Yeah, I could do that. Sure, let's try that. Oh, I think that works. Sure, that's pretty cool. Let's do that. Right. Right. So this guy's making some game. I don't think it's in C++, but it's in Lua apparently. So let's send him a raid. Maybe it's interesting for you guys. Right, and I'm gonna head off now. See you guys.